always you come up with either choosing a vertical or horizontal axis wind turbine, and always you should know or you should select based on the various advantage or disadvantage of wind turbine types. We have seen that horizontal and vertical has just its own advantage over another. So in choosing, always depend on the application, depend on the advantage or the behavior, depend on the system. You always select based on those two wind turbine and the types. So as it is written, two types of turbine design are possible. You can select either horizontal or vertical. In horizontal axis, it is possible to catch more wind. That is what we discussed. Depend on the blades. You can just easily just cover long distance, if I can say. And in whatever we will see, we will in the formula to calculate the outcome or the output of the wind. We will see that someone asked to put in a presentation mode, but the challenge is that if I go through the presentation mode, I will never be able to add those who are still joining. Maybe in 3 minutes I will do, because after 3 minutes nobody will be into the class. So then that is what I was saying. In vertical axis turbine, know your system is required. It means that even the more you reduce like the component of just a system, the more you reduce the cost. And as I told you last time, there are at least 4 parameters or 4 characters or 4, yes, let's use just parameters that you consider. You should always think about technical side, economical side, environmental, and as well as social. So in vertical axis, know your system is required. It is easier to design. Maintenance as well as is easier in vertical, where horizontal axis turbine offer better performance. Means that the horizontal one depend on how the braid of just the horizontal system is made. It is much easier to capture enough wind, and once we go to the formula, we will get how the length, which will be considered as the radius, will influence the power output. So now let's accept those who are requesting to enter. Then we close the class. Okay. Now, this is just like the main part of just the braid, as well as last time we discussed some part of just wind turbine, but the rotor is made by braid, hub, and of course the main shaft is just part of the braid. I mean the rotor. The portion of wind Of course, if we talk about rotor, means that is the one that will capture wind, which means that blade is part of. And the rotor can be either made in wooden, fiberglass, or metal. And of course, it might be horizontal or vertical, which determine two types of wind turbine, and that relate determined by wind speed and the shape of the blade. As I told you, it should not be like plane, or it's not just like a plane. It is somehow curved. So the blade are attached to the hub, which in turn is attached to the main shaft, just for rotating the horse. This is how it is made. Means that it is not just like captured or plain mode. It is not in plain mode. And with just a blade, this is like the technical side, where we have just angle of attack. Means that is the angle made by the wind which will hit the blade before it rotates. That is what I was saying. If like the wind, I mean the wind turbine system is fully closed, means that the wind will never enter and the blade will never rotate. So the chord line, and which is like the center, this is like the formation of the center of the wind blade, and the resultant one, there is just wind, because the wind is just coming from the outside of just the blade. Some will just need to lift up, like just taking the blade upwards, and while it is fixed on the hub, means it will never go and retain up, but it will create the rotational energy, and the force will be like the resultant. Means that there is just the wind speed which will just need to lift upward the blade, which is just a lift, and another one as well as which just make the blade to go like straight, straight, just to throw the path or the same path of wind. Then from there, it is where we have the resultant force, and those two as the center of pressure. Those two, it's like making the angle, one upward, another at the horizontal axis. And then the angle of attack, which is just a blade angle, which is this one, where the relative wind depend on the place or the position of this wind blade, and the angle of attack is just the relative wind, because the wind is just a wave. It is a wave where it will hit the blade. It will of course hit with a certain angle. If not hit with a certain angle, the blade will never rotate. And the angle between the chord line, which is just the line which is vertical, which is considered to divide, even though the blade is not just in square, to divide it in two, but it's just a virtual line which might be passed through the center of the blade, which like divide the blade into two parts. And that chord line, the angle of attack is when the wind is just hit the blade in the center, because as we umuntu uriya kumuterura neza atambitse wafata muri center, anybody or any object, just to hold in, and of course that is stability. To make it stable, nuko ufata muri center, and the chord line, it's like it is passing through the center, means that the relative wind or the wind which will just produce the considerable rotational energy, it is the one that will hit, because the wind is hitting any part of the blade, but the one which will hit from the center. And remember, the blade is heavy, so the one which will hit in the center, mainly it is the one which will create the rotational energy. So angle of attack has a large effect on the lift generated by a nail coil, and this is propeller efficient. Once we talk about the efficiency, and typically numbers here can range from 1 to 15 degrees. It means that this angle of attack which will hit the center, an example of just like a word gauge. Always you need just to focus on the center. Or if you need just to hold like a chair, always you focus in the center. Why? Because it is in a kind of balance. You are just dealing with the balance. It means that you can easily monitor or rotate the object. And angle of attack has a large effect on the lift, just to lift upward. And the more it is just going in upward, the more, of course, it will easily rotate. So, the determination of number of blade involve design consideration of aerodynamic efficient component cost. Some Europeans, they are not just using this system as power production, but as at least aesthetic. But in this, of course, you should consider. And one of the mainly, or currently, the main use of, or the main used turbine system are just the free blades. Not only presenting the efficiency, but as well as the aesthetic, because those three, as we said, the free phase and what, it is just making like a good cycle. And when it is rotating, it becomes, even the simple example that I gave you, we usually use those three, like a three system, because when it is rotating, it makes just easily aesthetic modern. And of course, even though the more you increase the number of blade, the more you increase the component cost. And of course, you will have an effect, power production. Hello, are you there?
Yes, sir.
Yes, lecturer. Okay. Then aerodynamic efficient increase with the number of blade, but with diminishing return. This means the more you increase the number of blade, the more you increase the cost. Generally, the fewer number of blade, the lower the material and manufacturing cost will be. And the higher rotational speed reduce, the torque is in the drive, resulting in lower gearbox and the generator cost. That is, even though we usually use, and that's why I said always in designing you consider 4 parameters, especially dealing with the cost. Otherwise, you can find yourself producing power which is higher cost compared to what is existing. So you can produce power useless. Let me use just the word useless power, because if currently the price of power it is on a certain amount, then you come up with a technology which will produce power which is costly, because always at the end you deal with cost of energy, and the cost of energy will depend on the investment and the maintenance, all the expenses related to the project. and you project from the return of just your investment. So that is aerodynamic efficient increase with the number of blade, but with diminishing return. Means that the more you increase, the more you increase the return. That is what they explain down there. Generally, the fewer the number of blade, the lower the material and the cost. So wind turbine blade design, even or odd number of blades. So a rotor with an even number of blades will cause stability problem for a wind turbine. The reason is that at the very moment when the uppermost blade bends backwards, because it gets the maximum power from the wind, the lowermost blade passes into the wind shed in the front of the tower. This produces an even force on the rotor shaft and the rotor blade. That is what I was saying. Just to understand this, you should always think about this blade. If it is just like a wall, the blade system or the rotation, cycle ifunze. That is what I asked last time. This blade, if the efficiency of just the wind which is passing through, if the efficiency is 100%, if I can say, because we know that it is just input and output. If the whole wind is not passing through the system, means that the rotation is zero, because the wind which will pass along the blade is the one that will rotate the blade. So means that the more we give space, as I told you last time, it's about 50 something, just the wind which will pass. Otherwise, if it is just, if the system, if I can say the system rotor, if it is closed, and you make it as a cycle, means that it will never rotate. The rotation is zero. So that will just create an even force, means that the rotor will never rotate the blade. So the more you give, if I can say, that is, I can even guess the reason why we are not increasing the number of blade currently. It's because the more you increase the number of blade, the more you reduce the power, I mean the wind which will pass through the system. Some blade. Once we increase some blade or we add some blade in the rotation system, it means that the more you reduce the wind, I mean the wind which will pass through the system. So, if I can use, means that you are just tending to have like a closed system. And if you have the closed system, that is what I was saying, that the wind will never rotate the blade. So those are just a blade. And remember, of course, these will have angular speed. And we know the formula to link angular speed with linear speed. At the end side of just a blade, we will be having the angular speed. I mean the linear speed. Means that the whole blade, this is the whole blade, will rotate with the linear speed. But considering that there is as well as the angular speed, which, and if we talk about the angular speed, remember it is just equal to 2 pi times the frequency. And the frequency, it means that is number of rotation. So, and the formula to link this is just that linear speed is equal to radius times the angular speed. And you see that the braid, that is what I was saying. Already we know that kinetic energy is equal to 1, even the square of a linear speed. Because we know that kinetic energy is 1 over 2 mv squared. And you can see if v is the square, which is equal to radius times this angular speed, it means that this radius, it is even square. Means it has a very significant role in the output or in the kinetic energy production. Because you can see this linear speed is mainly based on the distance or the length of the braid. And we have seen, last time I remember I told you, the most mistake most of students or others do is to forget that this is just the radius. The length of the braid, it is the radius already of the system. Because this hub is like the center, this will just create a cycle, and this is itself the radius. It means sometimes most of the mistake made is if saying length of the braid, some they consider it as just the length, then they to get the radius they divide by 2, like the distance, saying like it's like the diameter, or it is radius. And by considering this, the more this is wrong, the more you take the wrong braid, means the more you increase the kinetic energy. Because it is, remember the kinetic energy is depend on the mass and the velocity. These, if we go in energy storage, that is what we will be dealing with. The more you increase the weight of this braid, the more even you will easily maintain the speed when it is rotating. However, even by disturbance of this wind, because the wind, it can just, it is just as well as intermittent. If you go 55 meters per second, within a second it becomes 4.5. The more you have a heavier object which is rotating, you don't have to go. Near one to couple wind, even though it is impossible, practically it is impossible. It's a very experiment track. Okay, to have a wind, would you get to 4 meters per second with hitting this braid? It means someone is making noise. Who is it? That is what I was saying. This will have just a significant meaning, because by cutting just the speed of wind or the wind speed, completely, the system will not stop suddenly, if I can say. It will never stop suddenly. Depend on the mass of those braids. The more you increase the weight of the braid, the more the system will become stable. Now, even disturbed with just the variation or intermittence of wind, but it will just keep rotating. Because by just stopping even the wind speed, this will rotate at least for a certain minute. When you give a speed, of course, you will never suddenly stop. That is what we, if we say the intermittence, it is like a solar. Solar due to that intermittence variation in region hill. Mukanya fatri ufata wenda insolation ingana gucha, mukanya biragabanutse biriyongeye like that. So of course the wind depend on the weight of this braid. Niyo yagabanuka akandi kanye kiyongera akandi kanye like that. But depend on the mass of this braid, it will keep just rotating. and it maintains that kinetic energy, which just causes the motion. Now, as I told you last time, this is just some turbine operation where we have at least 4 phases to be considered, where we have rotor when it is locked, we have cut-in speed, we have rated wind speed, and cut-out speed. Those are mainly 4 technical side that you should know. When we have currently, and as I told you, when you go through, if you go through the current research, as I told you, they are just looking whether they can just make a wind system which can even work less than 3 or 2 meters per second. Kuko ahantu henshi in the world, the speed, even in Rwanda, the reason why we are not producing from wind is just due to the wind speed that we receive in our country. And if we are able, or if technically we get a wind turbine which is just able to produce even in less than this power, we might just be appreciated. Even in micro or mini grids, like. So normally, if the wind is less than this one, the rotor is locked. You know, we say the rotor, and the main part of rotor is blade. Means that wind speed is too low for generating power. Turbine is not operational. Means that it's not rotating when the wind speed is less than this. And in Rwanda, it is daily. And even according to what I saw from the researchers, even an area that sometimes have 4.5 or 5, it is in eastern Rwanda. It is in eastern Rwanda. I think it is on just a west, meteorological mast or station of Kayonza, I guess. It is where we are able to have at least 4.5 meters per second. So it means that less than this, when it is varying between 0, when there is no wind, of course, it is likely to have 0 meters per second. But when it is less than 4.4, let's say 4.5, it is not really possible to produce with that wind speed. That is the phase 1. And when it is just varying between 4.5 to 11.5, if I can say, it is just the minimum operational speed, which is called the cut-in speed, where generated power increases with the speed. Means that at least we can produce between 4.5 to 11.5. Now 11.5 to 22.5, it is where we can produce at its maximum. Of course, for the cutting speed, we can produce anyway, like if it is designed for output of 5 MW, not at its maximum, but to get the maximum, and that is what we call the rated wind speed. Is just rated wind speed. It is when we can just produce the maximum of the designed. Just the rate designed is where we can have the maximum. So now when it is beyond 22.5, that is now where the control play comes. Among what we have dealing with the part of wind system, I mean wind turbine system, it's where the control plane in is where now the system stops. just to prevent the failure. As I told you, wind speed, when it is become higher, the highest wind speed that I was saying is that below, above 22.5, means that it can break the system. So that is where those breaks comes into just as control. So those are just a conversation, because we have seen like mile per hour, mph, it is mile per hour. As I told you, sometimes if you read like some books, American system, they use mile per hour. So mile per hour, this is just formulas to convert mile per hours, which just read to this. Means that if we have 10 mile per hour, means that is 4.47 meter per second. Those are just the conversion. So wind turbine, there is just a cut-in speed. Cut-in speed is the minimum wind speed at which the wind turbine will generate usable power. This wind speed is typically between 7 and 15 miles per hour. Sometimes they said 3.5 to 7.5. This, you see, it is a little bit different to this one, because they said rotor is locked up to even 4.5, while to this case they said from approximately 3.5. Always the research currently, as I told you, the research are focusing on the improvement of wind turbine. It means depend on the efficiency of wind turbine you can produce, as well as to 3.5. What manufacturers are doing with, what manufacturers are fighting for, is just is the efficiency of wind turbine, up to even they can produce when you have wind speed of 2. That is, you can just go and do some research. And as I told you, the end, like the closing day of this module is just to present. And the presentation is where you will go and read about just what are people researching for, or how it could be like applied in what. And we have wind speed which can help in generation, we can produce. So rated speed, this is normal when we talk about the rated value. It means is when we can produce at maximum. The rated speed is the minimum wind speed at which the wind turbine will generate its designed rated power. Means that, for example, a 10 kilowatt wind turbine may not generate 10 kilowatt until wind speed reach this one. As an example, rated speed for most machines is in the range of 25 to 35 miles per hour at wind speed between cut-in and rated. Means that in cut-in speed, you can produce, but not the maximum of the designed rate of power. So the output of most machine levels off above the rated speed. Most manufacturers provide graphs or the power curves showing how their wind turbine output vary with wind speed. That is what I was saying. Means that from 3, there is a certain output, production. At 5, there is a certain output. At 7, there is a certain output. And then, for example, if it goes to 35, it attains the maximum. It attains the max, sorry, I'm back. So those various power that are producing in various like speed will make what we call power curve. I can see someone is saying more students want to enter the room. Lecturer, permit them, please. Sorry, I think I gave just some. It was clear that we will be closing at 8:25. So tell them to go to their other business. So that is those various value of production. That is what will make power curve of wind turbine. And cut out, this is now when it is at its maximum of wind, and we have seen it is above 22.5, which can just, this at a very high wind speed, typically between those per mile per hour. Most wind turbines stop power generation and shut down. The wind speed at which shutdown occur in called the cutout speed. Having a cutout speed is a safety feature which protects the wind turbine from damage. Shutdown may occur in one of several ways. In some machine, an automatic brake is activated by wind speed sensor. That is what we discussed the last time. Currently, they are using sensor just to because already there is a way to measure the incoming wind. Then, so still others use spoilers, drag flap, and so forth, things that you can read. So now, those are just now the output power of wind system. Those are just the 5 things that we should think about. There is a density of wind, which is just determined as a mass over volume. Means that if we talk about volume, remember it is like a cycle. Depending on the braid, it's like they are just making a container. They are making like a container. Because the braid are just those who are capturing the wind. So means the more they are rotating, it's like they are just capturing wind in a container of a certain volume as well as mass. So that density. And the volume, we know that is the area times length. And this length, remember, the length, it is as well as the distance of braid. Means the distance of braid, we created a certain area, and of course the more you increase the length, the more you cover the long. Velocity is the length over time, which is meter per second. Here will depend on the length of the braid. And energy, which is joule over second, means that it is just energy over time, and the kinetic energy, which is no more known, is just 1/2 meter, mass times the velocity square. Means this kinetic energy of a braid, it is just the mass of its braid times the velocity to which it is rotating. And come up with an equation for power which is equal to energy over time, or work over time. And work is being considered as kinetic energy, because the work done by a braid is the energy produced. That is the work done. So, and by replacing is kinetic energy over T, which is equal to the value of kinetic energy over T. And then we know mass, we can replace by density by volume. Here, mass might be it is just equal to mass might be replaced by density times volume, and we know that this volume is just area times length, which is here, and this we know that this area, we know that length over T is velocity, is distance over time. this distance over time, it is velocity. That's why it becomes v power cubic foot is depending mainly by density, area, and the velocity. And the velocity is power 3. To mean it is much influencing the output. It is much influencing the power output of a system. So here it is like the moment, small change with elevation and temperature, which is the density, and the density always, because it is volume and watt, and the area, it is in meter per second, squared effect of change in radius, because the area, it is like the area of, to calculate the area of this system means that it is to calculate the area of a cycle. How to calculate the area of a cycle? Because the blade will rotate with area, and that is the cubic effect. Because the velocity, it is cubic. Like the cubic means that the velocity will influence the system at its max. Those are just the demonstration. Let's check our unit. In this case, it's like a dimensional analysis in physics. In physics, that is what we call dimensional analysis. Where let's check our unit where we have this. Means that each can be replaced by its unit, which is just that is what I was saying. And density, it is just mass over volume times area, which with this unit, mass times power 3. I mean meter per power 2 times this. And it's a matter of simplification where we cancel, where those meters can be cancelled and remain with the second, and this kilogram meter per second over S3. Those are just Newton, can be written as kilogram meter per second square. So means that kilogram meter per second square means that can be replaced by Newton, remain meter and the second, and the Newton meter, which is just power times work times distance, is just work. I mean force times distance, which is the formula of work. Work is equal to force times distance, which is Newton times meter, and it becomes joule. And joule over S, it is watt, which is means it is just work over time, which is power. Power in physics, power which is equal to work over time. So this is just an example. The swept area, if we talk about the swept area, means that is the area covered by the wind turbine. The covered area by wind turbine, because it will be like which is equal to pi times radius square, which is the area of a cycle. This is how to calculate the area of a cycle. And this is just like an example of a region where there is just like rotation of an object, I mean of the speed, the blade, with the hub, with a tower of 10 meters, means that the system is in 10 above the ground, and it is producing this, means that it is by calculating and you get the output power. So those are just the simple example of calculation. And as I told you, this is like an example. one formula as we have in like power generated by horizontal wind turbine. How much power a wind turbine with this meter long can be generated with a wind speed of 12 meters per second. The site of the installation is about 10 feet above sea level, and wind to hit the place where it will easily just rotate the object. So now that is just the formula, means that even though in the previous formulas there is no efficiency, but remember and what about all those messages? Oh, from WhatsApp, sorry, I didn't close the WhatsApp. Okay. So the power output, where we have this wind turbine, is just a matter of replacing. We have just this, have area, and area should be calculated is pi radius square, and the radius is just the length of the blade. Then you get the output of this wind turbine, it is 3.15 megawatts. Where we assume that the turbine efficiency is 40%. Now, what we will be calling belt rate, which is related to wind turbine efficiency, it is the flow of air over the blade and through the rotor area that there is just a theoretic. Anyway, in summary, the wind turbine extracts energy by slowing the wind down, and the theoretical maximum amount of energy in the wind can be corrected by wind turbine rotor, which is that is what I was saying, which is estimated to 59.3, and this value is known as belt limit. If it were 100, that is what I was explaining. If the blade were 100% efficient, a wind turbine would not work because the air, having given up all its energy, would entire stop. In practice, the correction efficiency of rotor is not as high as 59%. The more typically efficient is 35 to 45. This is just the normally or the typical efficient of wind turbine. To me, this is the max, the limitation, which is bet. If we talk about bet limit, or the bet means that it is always called bet as the name of the scientist, which give the assumption. Means that if it is 100%, that the rotor is like a wall. Wind is a then ihagarara. So the maximum, which as well as this bet limit, will help in considering the number of blade. Because the more you increase the number of blade, the more you reduce the efficient. I mean, you increase the efficient of wind turbine. And the more you increase, means that you utangiye kugenda utending a very, you tend to 100% efficient. Because the wind system of 6 blade means that you are just tending to increase the efficiency of wind turbine, which is long. We could belt limit. So wind turbine doubling the tower height increase the expected wind speed. That is, about the system. Kuki hatabaho like rooftop system, because the more you increase the height, the more you can capture a good wind speed. Mostly in our country or generally, when we was meteo, musanga bapima from 10 height, I mean 10 meter height. Sanga ariho bafatira ibipimo. Means that wind speed which is 20, you are doubling. By doubling the tower height, generally you require doubling the diameter, as well as increasing the amount of material by a factor of 8. Means that the more, of course, the more you increase the height, I mean the tower, the more you increase materials, the more you invest more. And if you invest more, cost of energy as well as increase. So at night time, or when the atmosphere becomes stable, wind speed close to the ground usually subsides, where at the turbine altitude it does not decrease that much or may even increase. As a result, the wind speed is higher and a turbine will produce more power than expected. Doubling the altitude may increase wind speed by 20% to 60%. So that's why within this concept, that's why in the designing the hybrid of PV and wind is the best, because during the night, of course, is where you can easily capture a good wind. Meaning that it is the wind system is just working efficiently during the night. Then, of course, it will always depend on the wind speed, but normally a good wind is just appearing during the night. And remember, maybe, and as I promise, remember the reason why this statement can be correct. Remember, there is a relationship between irradiation and wind creation. Even though I'm still remembering that Dr. Pankras will have like a 1 hour or 2 hours session explaining us the wind formation. And remember, the wind formation is related to irradiance. And during the night, remember, means that there is no those I mean, the irradiance is less. So means that during the night, what we receive at the if you remember well, even though we have no sun, it doesn't mean that we have zero irradiance. Remember well, we have discussed that last time. So, and the tower height approximately 2 to 3 times the blade length have been found to balance material cost of the tower against the better utilization of more expensive active component. Means that the tower can be considered as the 3 times. If I have a 2 meter length of blade, means that the tower, it is 6. Means that tower height is approximately 2 to 3 times. So tower and blade of length of blade has a certain relation. Now, what we will be calling tip speed ratio. The tip speed ratio is the ratio of rotational speed of the blade to the wind speed. The larger this ratio, the faster the rotation of the wind speed, turbine rotor at a given wind speed. Electricity generation requires higher rotation speed. course, because we know that kinetic energy is essential. And remember, if we said rotational speed and braid to wind speed, remember the wind has its speed. And the speed of wind, it's not the same speed as of the rotor. Take in mind, the rotation, I mean the wind itself has a speed, and it will cause the rotation of a braid. So the more that ratio means that the rotational speed of the braid to the wind speed. The faster the rotation of the wind speed, the rotor at a given speed, electricity generation requires higher rotational speed. And the rotational speed, we know it is caused by the wind speed. Lift type wind turbine have maximum tip speed ratio of around 10. So those are just given the high rotational speed required of electrical generator. It is clear that the lift type wind speed, the turbine is the most practical for this application. Remember, if we go previously, there is wind which will make a wind turbine to go like upward. Another, it is just make just horizontal in the same speed of the wind. So now the number of blades in the total area they cover affect wind turbine performance. The wind must flow smoothly over the blade. To avoid the turbulence, spacing between blades should be great enough. If we talk about just the spacing between blades, remember that is in ratio with bed limit. The more increase the distance between, or the space between blades, the more we decrease the turbine efficiency. So, and it will easily the airflow, because the more increase the number of wind speed, the more the air which enter the space will decrease. What we are just discussing, but in a technical aspect, means in this kind of area, if it is free closed, means that it will be like a wall. That is what I was saying. But this blade to rotate, it means that it will need the wind which will hit a blade with a certain speed. So tip speed ratio is the ratio of the speed of the rotating blade tip to the speed of the free stream wind. There is an optimum angle of attack which creates the highest lift drag ratio. Because angle of attack is dependent on wind speed, there is an optimum tip speed ratio. And remember, this rotational speed, remember there is a relation between a linear speed and the radius. So the rotational speed times radius over velocity. And this, if we talk of velocity, means that is the wind speed. There is a rotational speed, and the rotational speed here it is, means that it is a number of, if in 1 minute you can just cover like 50 rotation, means that it increase the number of frequency. And the more increase the number of frequency, the more it will affect the output. So the rotational speed over the wind, or the wind speed or wind velocity, it will just determine the tip speed ratio. So those are just like recalling the previous. Inside this combustion generator convert mechanical energy of the turbine to electrical energy, which is electricity, and it is explained with just the AC what inside this component coils of wire are rotated in magnetic field produce electricity. Different generator design produce either AC or DC. Available in range blah 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 120. Some appliances can operate on either AC or DC. So always this is now the system that we've seen previously, where if it's required we can just use other conversion appliances. Those are just the typical aspect of or stories about the production. Wind turbine with rotor blah 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 that are about 8 feet in diameter and generate about 75